Hello everyone, this is Tutorly Tutoring and this is our video on our first lesson in the linear relation strand in the subject of math. In this lesson we will be covering things such as how to derive a formula, an equation from a pattern or of a linear pattern, how to identify a linear pattern, and how to graphically represent this pattern, and how we can derive the equation from the graph as well. So to get started, what we're gonna do is I'm gonna create a pattern. So let's say we had a pattern such as 3, 5, 7, and 9. So based on this pattern, you can see that for each value, we're adding by 2, right? That's pretty self-explanatory. And we can kind of give terms to this pattern. So we can call the 3 term 1, the 5 term 2, and the 7 term 3, and so on. This would be term 4. And so we can see that for each term we are adding by 2. And because of this, we can easily see that the next number will be 11. But what if we wanted to find the number for term number 121? Right, that's not so easy to just quickly do in your head, right? And this is a very simple pattern, but for more complex patterns, it's very impossible and hard to do. And there's an easier way to do it, and that is why we create an equation. So what I'm gonna do now is I'm gonna quickly erase this, and we're gonna restructure this into a table. In our table, we're gonna have the term number and its corresponding value. So we're going to have 1, 2, 3, 4, and 5. And from our pattern that we just had, we remember that it is this. So now we can see more clearly that for each increase of the term number by 1, we're adding 2. Right? And this tool is important as we can use it to create an equation that will allow us to get the next value. And what I'm going to do now is I am going to change the names of these into a more algebraic notation. We're going to call this x and we're going to call this y. So this is x, our independent variable, and y, our dependent variable. We call these things because the value of y solely depends on what x is. So that's why we call them that. So now looking at this, we can see that for each increase of 1 in x, we get an increase of 2 in y. So we can say y is equal to 2x, right? And this is not our finished equation, but this is what we have so far. And let's try to work it out. So let's plug in x to 1. This would give us 2 times 1, and that gives us y is equal to 2. But we can see this is not correct, as y is 3. Okay, so that's not right, but maybe it works for the other values. So let's try it for the next one. Y equals 2 times 2, y equals 4. Well, that's not right as well. We can see that it's supposed to be 5. But based on this, we can see there is another pattern that emerges. When we do this, it's always 1 less than the value of 2. Sorry, of the y value. For example, when we had plugged this in, it was 2 instead of 3, and for here, it was 4 instead of 5. So to fix this, what if we just did 2x plus 1? Let's try this out now. Let's see for this one. So y is equal to 2 times 4 plus 1. This gives us 9. So we can clearly see that this equation works. So now we've actually created an equation. Y equals 2x plus 1, and that is the equation for this pattern. And now I'm going to show you, we know how to get this value over here, right? We got it by seeing how much the y value increased. But how do we get this value for any pattern, not just this one? Well, we're going to look at this and go one step back and add 0 here. When we add 0 here, the value of y that would be the same thing. It would decrease by 2 here because we're going back, and it would be 1. So this tells us that when x is 0, y is 1, and it continues that same pattern. And for any linear relation or pattern, the equation to get this value will always be the value of y when x is 0. This is also known as the y-intercept, which I will show why in a second. And now what we can do is create a standardized equation that works for everything, and that is y is equal to mx plus b, where m is what we call the slope, and the slope is the same thing. It's the value that it's how much the y value increases for when the x increases by 1. That's our slope. I'll also give a better definition soon, but that's slope, or m. Now, b is the y-intercept, or the value of y when x is 0. So now we've made our equation. Why don't we find the answer we were now looking for? So we have y is equal to 2x plus 1. Now let's plug that same thing in. We wanted to find the y value when x was 121. Let's see. So now we can plug the equation in. Plus 1. This would be 242 plus 1, and that's our answer is 243. And we got this because of this equation. I didn't have to continue this pattern, which would have taken me a tremendous amount of time more. Now what I'm going to do is create a graph for this representation. And we're going to do that right. Okay. So I'm gonna go by 2's just because it is small. Okay, so now let's plot this on the graph. So we know this is our x-axis, this is our y-axis. So when x is 0, y is 1. So let's plot that down right there. When x is 1, y is 3. So let's plot that down. Okay, so this would 3, and that's when x is 1. So when x is 1, y is 3. So that right there. Now, when x is 2, y is 5. Okay, when x is 3, y is 7. When x is 4, y is not 9. When x is 5, y is 11. Okay, we know 0. And when one thing to mention is this also works for the negative. So for -1, it would just continue the pattern backwards, and this would also be -1, since 1 minus 2 is -1. So this would be right here, -1 right there. For -2, it would be -3, and for -3, it would be for -3, it would be -5. There, there. Okay. So now what we can do is connect to these dots. Sorry about my drawing. Okay, let me just redo it. That's fine. Okay, so this is our line. Now, this is the representation of this pattern and the equation we made. Now, I'm going to show you how you can get the equation from the graph itself. So first, the y-intercept, that b value, we get by looking at when the line intercepts with the y-axis. And we can see that it's when the line hits the value of 1. And this is why we call it the y-intercept, as it's when the line intercepts the y-axis. So we know that value. We've established that. So we can say that y is equal to mx plus 1. But now we need the m. What we can do now is see that use what is called rise over run. So we start here, or it could be any point, but I'm going to start here at the origin, or above the origin. So we know this is the 0, 1. We're going to move to 2, and we're going to go up to 2, which is 5, right there. So this is 2 because this here is 0, this is 2. We know this is 2. Now, that's our base. It's a right triangle, as you can see. Think of it like that. Now, our height here, we're going to get by seeing this starts at 1, and this is 5. So that is, one second. Yeah, so this would be 4 because it starts at 1 and we know it ends at 5. So 1 to 5, 5 minus 1 is 4, so our height is 4. So what we do now is called the rise over run, which is getting the height and dividing that by this base, which gives us our slope. This equals 4 divided by 2, which equals 2. And as you can see, this is our slope. So now we can finish the equation. Say that y is equal to 2x. So this is how we get an equation from a graph of a linear representation. So I think that's everything I wanted to cover for this first lesson, and this was a basics of linear relations. And most of you who are probably watching this video are probably in 8th or 9th or 10th grade, one of those, I'm guessing at least. And so I'm hoping you find this useful just to learn the basic concepts, and we will be soon covering more advanced concepts as we go. And so this was Tutorly Tutoring. Please look through our page for more videos if you're interested, or contact me personally and we can set up, if you require more assistance, and we can set up a date where we can have a private tutor session. And so with that, I hope you guys learned and enjoyed this video, and have a great day.